Hello everyone, welcome to another problem session. So today we have a theoretical question uh, which given this situation where you have two frames, they overlap at when they overlap completely at that time. T is 0 in both frames. So here's a kind of reference, you can say, when they overlap, T1 is 0 and T2 is 0. So we synchronize two of them at that instant. Then if you look at a particle which is moving and you observe from these two frames, they will assign different coordinates. So frame 1 might assign x1, y1, z1 and assign time t1. We already know times are frame dependent in relativity. And frame 2 will assign these coordinates at a different time. And their relations are called Lorentz transformations. So I would definitely say memorize this. Memorize this with that figure. With that figure. Because you can see if I call this guy 1 and this guy 2, this will be, if I write the diagram, so this diagram is basically, we say we're writing it in frame 1. So if you, this diagram is set to be written in, or drawn in frame 1. Because in frame, whatever frame you're going to draw it in, is that frame will be at rest. So this is like this one is at rest, this is moving. But you can see that I could have drawn this guy y2, z2, o2, x2, and then we would have the other guy x1 moving this way with minus ui hat, y1, z1, o1. So this will be, when you draw something like this, you say I'm drawing it in, drawn in frame 2. And they're kind of equivalent. When you do this, you can see I'm going to have a T2. So you will say, what is T2 equals to? All I have to do is the U has to go change. Gamma T1 minus U over C square x1. And x2 will be gamma x1 minus u t1, and y2 equals y1, and z2 equals z1. So this is a sign that's going to flip. That's why you have to memorize this with the figure that goes with it. Okay. Now the question is, not only this will be different, it will also assign, frame 1 will assign a velocity v1, and frame 2 will assign velocity v2 for at the same instant. So velocity v1 is at time t1, at instant t1. That's the frame 1, and this is going to be instant t2. So if you look at, suppose you're just working on frame 1, you're going to have a v1, x will be, the x component will be just this dx1, dt1, right? And v1y will be dy1, dt1. So its own times, it doesn't know the other frame exists, right? v1z, so it's just doing your regular kinematics. And similarly for v2x will have its own x and its own t, so it's going to use its own dx2 dt2, and v2y will have a dy2 dt2. v2z will have a dz2 dt2, right? Okay, so now if I want to write v1x in terms of these guys, only these guys are not using these other guys, what will be this relationship? That's the question. And you probably see that right away I could start like a v1x. I could start dx1 dt1 by the definition, and then I will say, well, this x1, I can have a derivative of t2, and then I can write d2 in terms of this, right? So we can have a dx1 dt2 and then dt2 dt1. So you can see just using calculus I can write this, right? Well, okay, so let's work this out, and I'm going to kind of erase some of this to get myself some space. All right, let me erase some. Okay, so I erased and got some space for myself, so I can work out this using this equation, and work out this using this equation. Okay, so it looks like I'm gonna get a gamma. Gamma is a constant. Remember, gamma is 1 over a square root of 1 minus u square over c square, relative speed is called. So get a gamma, and when I go with respect to t2, I get a 1 here, and for t2 this gives v2x, u over c square v2x, times I get another factor of gamma, and then x2, I mean this one t2, this, so when I, no, this one works with that, no, still working out. This x1 was with this guy, not with that guy, and this with this guy. The t2 is that's why the minus sign was important in our discussion. So this is this gives me 1, and when I go out, this gives me v1x. This is v1x. So this gives me minus u over c square something wrong. I actually made a mistake here. I can see. So let's do it one more time. So using this for x1, so I get gamma v2x plus u times 1, and then using this I get a gamma 1 minus u over c square v1x. Now there is a v1x here and there's a v1x here, so I need to combine them, and there's a gamma here, so this makes it gamma square. So gamma square, you can see, bring on the other side 1 over gamma square v1x equals to v2x plus u, and then I open this up, 1 minus u over c square v1x. Now this times that, bring on the other side, and this guy express that as 1 minus u square over c square v1x. So this stuff is that, and bring this becomes plus from uh, you can have plus v2x plus u times u over c square v1x. Excuse me. Okay. And then on the other side it's just factor times 1 v2x plus u. So you can see that this with that, this will cancel that. So this with that, this factor in there cancels that. So v1x it's simply 1 you have a 1 plus u v2x over c square, everything multiplying v1x equals to v2x plus u. So v1x is simply v2x plus u over 1 plus u v2x over c square. So that's the relationship for v1x. So on this side is all in second frame plus relative. Okay, it uses relative speed information, and this side is all in frame 1. Okay. Okay, so we want to do v1y. So v1y is not going to be v2y. v1y is not equal to v2y, even if there's nothing happening in the y direction. Let's work out the whole equation. v1y is equal to dy1 dt1. Because this I want, and this guy is with a very different time. So we'll have a dy1 dt2 dt2 dt1. So y1 is y2. So this is going to be y2 simply. dy2 dt2, and then this one we worked out from this stuff, and that's gamma times 1 minus u over c square dx1 dt dx1 dt1. So this thing is let's start the gamma over here, and this is v2y from here, and 1 minus u over c square, and this is v1x. So actually when you want to write v1y, it uses v1x, and if you want, it will be quite complicated. So v1y will simply be gamma v2y 1 minus u over c square v1x. So over here, this side is you can see this is the two. This is in frame 2, but this one is in frame 1. I want this side all to be in frame 2. So we can see that this probably much easier to solve for v2y than v1y. So let's write solve for v2y. So v2y is 1 over gamma times 1 minus u over c square v1x, and this is v1y. So this side is all in 1, and this is all in 2. Okay, you can clearly, there's a symmetry here. If I switch the sign of u and 1 to 2, so if I switch 1 to 2 and switch u to minus u, I should get what I need. So v1y should be equal to v2y 1 plus u over c square v2x. This is pretty cute trick. You can just go use the symmetry of the situation to go something that can be nasty. Another way to do would be a nasty way. Okay, a nasty way would be to put this guy in here, and so write v1y equals to gamma v2y 1 minus, and do the whole thing over u over c square v2x plus u over 1 plus u over c square v2x. Now, if you were to simplify it, you should get this, and let's see if I get that. Okay, so you have a u over c square times this, and so let's say gamma v2y. So have this whole thing, this have multiplied that guy, and so your denominator is 1 plus u over c square v2x, which is kind of like that. And then you have a 1 minus u over c square v2 1, I mean this 1 plus this guy with 1 v2x, and then so this is from 1, and then minus u over c square v2x minus u square over c square from this multiplying. So you can see that this thing cancels this thing, and the numerator just cancels gamma with a, so the numerator is actually 1 over gamma square. So actually from here I see that there should have been a gamma here. So this gamma cancels one of the gamma, and so the answer is, oh, it's a good thing we did the long way because I caught the error here. v2y is gamma 1 plus u v2x over c square. So whether you go a long way or you just make a trick, because I kind of forgot that gamma was hiding there. So either you do symmetry or you get this answer. Now you don't have to do the z part. The z part will be identical, right? Okay, so when you look at the situation here, you completely y and z are in identical situation because the only motion of the frames is along the x-axis. So v1z will be very similar to that. All I have to do is y to z in this formula. So we have v2z over gamma 1 plus u v2x. I keep the x, okay, because I'm not switching x, c square. So these are the velocity addition rule. Now if I wanted to go other way, if I want to go v2x equal to what will be, all I have to do, u has to be changed into minus u. So v1x minus u, 1 minus u v1x over c square, v2y will be v2y over gamma 1 minus u v1y v1x over c square. v2z is v1z over gamma 1 minus u v1x over c square. Okay, I just want to say, suppose we have gotten through this and I want to work out acceleration relation. What should I do? And I'll show you what the nastiness of the calculation for acceleration will be, I'm not going to complete it. I'll leave that as an exercise. Actually, it's a good exercise for students to do. You know, all of these calculations are very instructive. And so let me try my hand. What will I do? How about acceleration 1x equals to what? So acceleration 1x, in the acceleration of this particle in frame 1 will be dv1x dt1. So it's going to be as if I'm in that frame. So v1x is this guy over here. So I'm going to get dv1x, but I want to be everything into second frame. So I'll have to take derivative of this with respect to the second frame, and which means I need to do this one. So this was the same as before. So we just work it out here. And so we are going to have d over dt2, and you have a v2x plus u over 1 plus u v2x over c square. So everything is going to be in the second frame, so no problem there. With t2 I do this gamma, t1 gives me 1, but this one is u over c square dx1 dt, that's a dx1 dt1. So that's just a velocity in frame 1 v1x. So we can just insert that over there, and so this whole thing can be written. So this whole thing over here will also be in 2, and this will be also in 2. Now this is pretty nasty, right? You can see that I will have to do a product rule, you know, over here. And if I do a product rule, when I go numerator, I get a2x plus 0, and so denominator remains the same. And then I have a minus denominator square, and you have a v2x plus u times the derivative of this. So this is 0, so 0 plus u over c square a2x, and then you have this stuff over here. So this is pretty nasty. You can do actually very you know, a lot of algebra, and it's not too much trouble. It just this is kind of like a messy algebra. Okay, so you can do acceleration on your time. I'm going to stop here.